The Compton Effect is an experiment that confirms the quantum theory of light. It was conducted by Arthur H. Compton in 1923. Compton basically directed electromagnetic waves with short wavelength known as X-rays at stationary electron, and he examined the collision between those waves and the electron. Now he found that the incident electromagnetic waves had slightly shorter wavelength than the waves produced after the collision. So, to see what we exactly mean, let's look at this diagram of the collision taking place between the wave and on the electron. You can see the incoming incident X-ray that has a wavelength given by lambda, which shown by the following wave. On the other hand, we have the stationary electron. And when the collision takes place, basically some of that energy of the X-ray is absorbed by the electron, and the electron moves away at some angle phase with respect to the horizontal axis. And now, the rest of that energy of the X-ray is essentially scattered at an angle phi with respect to the horizontal axis. And what Compton found was that the wavelength of the scattered X-ray was slightly larger than the wavelength of the incident X-ray, and this in fact became known as the Compton Effect. Now, using the conservation of momentum and the conservation of energy, he was able to derive the equation lambda, the prime lambda, is equal to the lambda plus the Planck's constant, which is symbol as h, over the mass of the electron multiplied by c, or the speed of light, multiplied by 1 minus cosine of the angle phi. The angle phi is the angle between the horizontal axis and the scattered X-ray, and our lambda prime is the wavelength of the scattered X-ray, and our lambda is simply the wavelength of our incident X-ray.